ready. Carrie, what section is it?
3.4.
3.4. There are two main things in 3.4. The first one is trigonometric limits. The second one is trigonometric derivatives. There are two fundamental limits involving sine and cos that we want to establish first. And we're going to use those to find out answers to other limits involving trig functions. The two basic limits you want to memorize are these. The limit of sine x over x as x goes to 0 is 1. And the limit of cos x minus 1 over x as x goes to 0 is 0. Okay? Okay, so just memorize them. Memorize those two things. We're not going to prove them. We're going to use them. We're going to use these two known results to talk about other limits. For example, number 7. Number 7. The limit of sine 3x on x as x goes to 0. I want to find out about that limit now. We know if it were just simply sine x over x, that this answer would be 1 already. It's sine 3x over x. So what I want to do is I want to get it into a state to where it looks very similar to this, but it won't be exactly like that. The usual trick is, the idea is, whatever the argument inside sine is, argument inside sine should be the same as the denominator. Okay? So the argument, in this case, over there, it's just x. The argument inside sine is x, and the denominator is also x. And if x is going towards 0, then it's going to head towards 1. Over here, I have 3x inside sine above, but only an x in the denominator. So I'd really like this x down here to read 3x. So how will I do that? Divide by 3. If I multiply the bottom by 3, I'll be forced to multiply the top by 3. Sounds reasonable. Okay? So this should be equivalent to this limit, 3 sine 3x over 3x as x heads towards 0. Now, this 3, this one up here, is constant as regards the limit. Okay? It's not influenced by x heading towards 0. So this 3 I can remove to the outside of the limit.
Why is it moving outside?
Because I'd really rather just have the expression lim, and then, as you see it over there, sine something over that same something. So I'm just removing this piece here to the outside, which is irrelevant as regards to the limit. Okay? We'll multiply it on afterwards. So 3 limit sine 3x over 3x. Now, there's a small technicality. It's not essential, but just to, I think the book does this, so I want to write it too. Here, x is heading towards 0, and x is the argument, and x is the denominator. But here it's 3x and 3x. Now, if x is heading towards 0, what's 3x heading towards? 0. That would have to be true. If x is heading towards 0, certainly 3 times that is heading towards 0. Right? So now it looks exactly like that over there. I can replace 3x with some other letter. We'll call it k. So this is very formal right now. Let 3x equal k. Okay? Then the last stage here, it would read 3 lim sine k, I'm going to sync, over k as k heads towards 0. So now, what is the parenthesized limit? It's 1, right? Sine of argument divided by same thing, as that same thing goes to 0, it'll be 1. So this will be 3 times 1, which is then 3. So all you're trying to do is to get this thing in the form of that first limit over there, okay? And again, this is very precise right now. This little substitution at the end, you know, when I learned it, I never did that. But I just noticed in the textbook, I want to make sure I'm doing it the way the textbook presents it. Okay, Roger?
Let's just do times a third. Start off with prompts so we get sine to get over 3x.
Times a third?
Yeah.
Well, that's what Lou said. He said multiply by a third. So I did. I multiplied the bottom by 3. That's the same as multiplying by a third, right? But that changes the whole thing. Only if I multiply by 3 over 3 does it keep it the same. Because I'm only multiplying by the number 1 now. Multiplying by the identity. So it keeps it the same. You can't just do a third on there without adjusting it in the numerator as well, you know what I mean? Certainly, I would have been satisfied at this point if you wrote 3 times 1, right? This extra substitution at the end, I said, is an additional, very specific feature, right, that the book uses. All right, let's try a different one. Again, the idea is to try to write it in terms of these expressions. Number 9 has tan in it. Lim of tan 9x, 5, tan 5x over x, as x heads towards 0. Okay? Now, on the left over there, we only have 2 limits. One involves sine, one involves cosine. We have nothing that involves tan itself. So we should probably
Put it in terms of sine and cosine.
could not agree with you more, Snyder. All right. Lim, x goes towards 0 of sine 5x over cos 5x over x. So what that really means is that the x is next to the cos 5x, right? We've had this before. Fraction on top of something, right? It just pushes down in a sense, and this denominator becomes part of this denominator. So really, without me writing the whole thing over again, it would look like that, right? All right. So now, this cos 5x has no minus 1 associated with it, so perhaps we could say it's